So let's look at something here. Right now, since we have already explained how you'll be able to find the area under and between curves, we want to dive into how you can draw the graphs of the given functions. So basically, most of the times they give you the functions and then they ask you to find the area between those curves. But how do you do that? Before you'll be able to calculate the areas between these two curves, you need to be able to just draw the function or sketch the graph of those particular function. If you are not able to sketch the graph of those particular function, there's no way that you can tackle such questions unless maybe it's just by guessing or something like that. So because of that, we are going to tackle on how to draw the graphs of these given functions when such questions are being given to you to determine the area under or between curves. So first of all, let's take some couple of examples here, and we are going to use those same examples we will be solving those same examples since we have learned about their graphs, right? But I have such examples here. So we will come back to solve such questions, but for this point, I want to draw the graphs out of such questions. So assuming that you have been given questions like determine the area between the curve y equal to x power 3. Please pardon me for that, it didn't come well. So if you see x and then 3 here, it's x power 3 minus x power 2. So power 3 and the x power 2. And then minus 8x and then the x-axis. So determine the area between the curve y equal to x power 3 minus 2x squared minus 8x. So let me write it properly here. Y equal to x power 3 minus 2x squared minus 8x. So this is our function. So before we'll be able to draw out the graph, what we need to do is to find the root of this function. So when you find the root is going to be the values of x, right? The root is going to be the value of x. So when you did your calculus 1 well, the roots are the point where the graph cuts the x-axis. So if the graph is going this way and it cuts the x-axis here, it cuts one here, it cuts one here, it cuts one here, it means that we are going to find one of the roots this place, we are going to find one of the roots this place, and then one of this place, and another root this place, and so forth and so on. So based on that, we need to find the root of such function. And finding the root of such function, we will be able to factorize x out. So therefore, we are going to get x out, x squared minus 2x minus 8. So based on this, we will be able to factorize the remaining quadratic equation. So factorizing the remaining quadratic equation, you're going to get x into brackets x plus 2 and then x minus 4. Now we can say that everything should be 0. Now we can say that our x is equal to 0, our x equal to negative 2, and our x equal to what? 4. So these are the roots of this given equation. So this means that given a graph like this, negative 2 here, let's say 4 is here, and then 0 is here. So given a graph like it means that the graph will pass through a point like this, and also pass through a point like this, and also pass through a point like this. Right. But the fact here is that how are you going to determine whether it's going to pass here minimum or it's going to pass here maximum at this point before it comes down or it goes up, right? That means, for example, is it going to start from down here and go up, or is it going to start from up here and come down? So this case, you need to determine where it passes. So in determining where it passes, we can see that if this graph that I've drawn over here, maybe -2 and 0, and here is 4. This is the graph. So we can pick a value between the -2 and then the 0. So the value between -2 and 0 is what? -1. And then a value between -0 and 4 is, you can pick 1 to make it easy as possible. So based on that, we can put this -1 into this equation. We can put this -1 into this equation. So when we put this -1 into this equation, what are we going to get? We are going to get -1 power 3 minus 2 -1 power 2 minus 8 times -1. And in this case, we are going to get -1, -2, and then here we get plus 8. And at the end of the day, we are going to get 5. This means that the answer is positive. So the answer being positive means that the graph, if it starts from here, it will move to the positive direction of the y, because now we found the value of y, right? It was the value of y, which is 5. So if here is 5, it will just pass here, so that the point here, the maximum, let's say the maximum point is going to be 5 before it come and cross 0. So before it come and cross 0, we don't know that whether when it got to 0, it automatically turns or it went down before it was turning. So in this case, we need to also pick a value between 0 and 4. And in picking such value, we would like to pick 1 because it will make our life easier. So picking 1 again, we can put it in the function, y function. We're going to get 1 power 3 minus 2 exponent 1 minus 2 times 1 exponent 2 minus 8 times 1. So in this case, we are going to get 1 minus 2 minus 8. And at the end of the day, we are going to get -9. So getting a -9, it means that between the 0 and then the 4, which is the root of the polynomial function, the function value will come down like this. If it was positive, it should have gone up immediately from here, but because it's negative, which is -9, we are going here before it was able to cut this point. Right, before it was able to cut such points. So in this case, the area that they are asking us to determine is the area between the curve and the x-axis. So in this case, when we are trying to just shade those area, this is the x-axis, remember. So the area will be here and then this place. So this is how we were able to come up with a graph. So let me go over it again. When you are given the function, you write the function down, and first of all, you find the root of the function. And I explained the root that anywhere the graph cuts the x-axis becomes a root of the particular equation. So in this case, when we factorize the function out and we were able to find the root, which is 0, -2, and 4, we assume that the graph cuts 0, it cuts -2, and also cuts 4. So, but the other one is that we didn't know whether after cutting the 2, it's going to go down, which is the minimum, or it's going to go up, which will be the maximum. We didn't know about that. In doing so, we needed to pick a value between the -2 and 0 to see the result that it was given to us. After putting that value in the original function, if we were able to get a positive 5, this means that after cutting the -2, it will move up to 5 before it turn and come and cut 0. After cutting 0, we also don't have no idea whether it was able to go up or it was able to come down. So in this case, we have to also pick a value between the 0 and the 4. And for that matter, we picked 1 and put it in 1, we were able to get -9. Getting -9 means that after cutting 0 over here, it's going to branch down and then go up before it can cut the value 4, which is also the root. So that is basically how you will be able to draw some function like the given that a question has been given and they are asking you to find a bounded area or the total shaded area. This is a very understandable topic, so I'll urge you to do more practice as well. Now, let's move to the second one. Let's look at how we will be able to find the graph of the second function. So the second function is telling us that we should determine the area enclosed between the curves y equal to x squared. Let me write it well. Y equal to x squared plus 1 and y equal to 7 minus x. So these are the two functions that we said we should find the area enclosed between the curve, these two curves. So in doing so, as I said, because we are supposed to find an area between two curves which is enclosed, it means that basically these two functions are supposed to meet at the 2 points, because they are two functions. They are supposed to meet at 2 points before we can know that they were enclosed. For example, if there are two functions and all of them are going parallel like this, how can we find the enclosed area between these two curves? But at least one can be straight line and then one can be like this, and you can see that it has been meeting in 1 point over here, and then therefore we can get the opportunity to know the area between such curves. So not to talk much about this, let's go ahead and see how we'll be able to derive the graph from this. So deriving the graph from, as I said, definitely this function must meet before we'll be able to find the area enclosed. So based on that, we can see that at the meeting point of these two functions, y1, assuming here is y1, y2, you can say y1 equal to y2. And therefore, at the meeting point, we can see that x squared plus 1 is equal to 7 minus x. And when we do that and we simplify it, we are going to get x squared plus x, and then x squared plus x. When we send 7 also here, we are going to get negative 6. Now everything is also 0. Now we have been able to find a quadratic equation, and we need to find the root of the quadratic equation. When we are able to find the root of the quadratic equation, this means that we have been able to find the cutting point on the x-axis, right? We have been able to find the cutting point on the x-axis for the intersection of the two functions. So based on that, I can factorize the quadratic equation. We are going to get x minus 2 and then x plus 3, which is equal to 0. And therefore, from which x equal to 2 and x equal to negative 3. So at the end of the day, we are going to get x equal to what? 2 and then x equal to negative 3. So now that we have the various roots of this equation, it means that we have been able to find the meeting points of the two functions. So firstly, we have to determine the point of intersection, the range of x values that has been found. So you can decide to use the tabular method to plot your function, or whatever you'll be comfortable with. So in using the tabular method, we can see that our x value here and we have our y value here. So our x value here, we are going to get negative 3, negative 2, negative 1, 0, 1, and 2. 1 and 2. And at the end of the day, when we do the substitution, which is y equal to x squared plus 1, we are going to get 10, 5, 10, 5, 2, 1, 2, 5. So this is what we are going to get. That means we substituted those range of the roots, right, into the original function, and we have been able to we'll be able to talk about that later. So now we have this point, and then we can also do same for the other value, which is x and then y. So based on that, the second function, if we pick a range of -3, 0, 2, we are going to end up having a y values of 10, 7, and 5. So now that we have such points, you'll be able to use such points to draw the graph. Or if you don't want to pass through this whole process, what you can do is that after determining the values of the two values of x, what you can do is draw the Cartesian plane and then tell yourself that the two values, we have one to be 2 and then one to be -10. So the values we are going to get, let me do it here. So the first one is 2 and then the second one is -3. So assuming here is my -3 and here is 2. So first of all, the first approach that we did here, you can pick a value between -3 and 0, or because it's just two functions, what you can do is plot it with these points given when we substituted it back. So that's what you can do. So now remember that the -2, the -3, and then the 2, they are the meeting point, the intersection point of these ones, and it also have helped us to find the range that we want. So doing that, now let's come to each of them. Now the x squared plus 1 is a quadratic function, and when we plot it, you are supposed to get a minimum, let me say, parabola. So getting this, you are going to get something like this, and then the straight line is going to get something like this. So based on this, you'll be able to know the area that has been shaded or enclosed, and then the limit is supposed to be -3 and then 2. And from there, you'll be able to calculate for your definite integral or whatever thing they are asking you.